Hi class, and welcome to another lesson. We're still on 9.3. This is our third day of it. Once again today we're going to be graphing rational functions. With these ones though, we first have to find the reciprocal equation and then graph it. So let's review on what a reciprocal is. A reciprocal is just flipping a fraction upside down. So here's 2/3, the reciprocal is 3/2. If we have a number such as like 4, it's going to be 4 over 1, so the reciprocal is 1/4. And that's kind of going to be the introduction to this lesson today. We have linear equations with all of these. Y equals x minus 3. This is a linear equation, right? So what we're going to do here is we're going to find the reciprocal of this. So its denominator is 1. It's x minus 3 divided by 1. So what is the reciprocal equation? G of x, that's going to be our reciprocal equation, is going to be now 1 in the numerator and x minus 3 in the denominator. So hopefully this first part is simple enough. All you have to do is put the linear equation over 1, so 1 is going to be the denominator, and then you just flip the fraction upside down. So 1 is now in the numerator, and x minus 3 is in the denominator. So this blue line right here, this is the function y equals x minus 3. That's that linear function. Now what we're going to do is we're going to graph the rational function, which is this one right here. So we talked about doing that yesterday and the day before, so let's practice that once again. We're first going to find our vertical asymptote. Our vertical asymptote is when our denominator equals 0. So when does x minus 3 equal 0? Well, quite simply, it's when x equals 3. So vertical asymptote is x equals 3. So let's put a dotted line at 3. Now the next part is to find any removable discontinuities or any holes in the graph. And on this lesson class, you're never going to have any holes. The reason for that is because your denominator is always going to be 1. So then your reciprocal equation, your numerator is always going to be 1. So there's never going to be any canceling of factors. So you don't even have to write removable discontinuity on this lesson. There's never going to be any. So now we're going to have our horizontal asymptote, and that one you're going to find in our graphing calculator. So please take that out and put 1 over x minus 3 in your graphing calculator. You press y equals, put the numerator in parentheses, which is 1, divided by, put the denominator in parentheses, which is x minus 3. And we graph this. As you can see, we have our vertical asymptote at x equals 3, which is good. It's right there. So now what you're going to do is you're going to find your horizontal asymptote. If you look closely at the graph here, it appears to be 0, and that's what it is. We could check it by using our table, but it is going to be 0. So y equals 0 is our horizontal asymptote. So I'll put a dotted line at y equals 0. So now what we need to do is pick 2 points to the right of our vertical asymptote and 2 points to the left of our vertical asymptote. Once again, we do that in our calculator. We press second graph, which is our table. And our asymptote is at 3, right here. So 2 points to the left. We have 2 points right here at 2, -1, and 1, -0.5. So let's put those on our graph. 2, -1. 2, -1, and at 1, -0.5. And then it's just going to follow these asymptotes. And then let's do the same thing for the right side of our vertical asymptote. And those are going to be at 4, 1, and 5. 0.5. 4, 1, and 5.5. And then those two, you're going to connect the dots with a line that also follows our asymptotes. So that's what I expect from you on these problems. And then finally the domain and the range. So the domain going from left to right, this blue line continues to go left forever and ever and ever. And then we go as far as our vertical asymptote, and it's going to stop right here but then it's going to pick up on the other side of the vertical asymptote, which is right here. And then it's going to go to positive infinity. So it goes from negative infinity all the way to positive infinity, except there's one number that x cannot be. So it goes from negative infinity all the way up until, whoopsie, negative infinity all the way up till 3, union 3 to positive infinity. Negative infinity to 3, union 3 to positive infinity. Which means that x such that x belongs all real numbers except 1. X cannot equal 3. Alright, now for the range, this one goes from a negative infinity. This blue arrow goes down forever and ever and ever and never stops. So from negative infinity, and then it stops at our horizontal asymptote of 0. It picks up on the other side of 0, and then it goes to positive infinity. So this one goes from negative infinity. Whoopsie, this should have gone here. Sorry about that, class. And this should have gone here. So for our interval notation, it's from negative infinity all the way till 0, union 0 to positive infinity. And then our range is from y such that y belongs all real numbers, except 1, y cannot equal 0. So that's what I expect from you on these problems. First, find the reciprocal function by flipping the fraction upside down. Find the vertical asymptote, the horizontal asymptote. Pick 2 points to the right of the vertical asymptote, 2 points to the left of the vertical asymptote, and then tell me the domain and the range. Alright, let's try number 2 together as another practice problem. Number 2, y equals a negative 2x plus 4. This is a fraction that is over 1. So now for our reciprocal function, we're going to put 1 in the numerator, and we're going to put a negative 2x plus 4 in the denominator. So there is our reciprocal function. Let's now find any vertical asymptotes that we might have. We're going to say, when does 2x plus 4 equal 0? Well, 2x equals a negative 4 when we subtract 4, and then divide both sides by a negative 2. So it's when x equals a positive 2. When x equals 2, there is going to be our vertical asymptote. So we draw that using a dotted line. To find our horizontal asymptote, let's use our graphing calculator. So let's erase our last one in our graphing calculator, and let's put in this reciprocal function. So going to our calculator, y equals the function 1 divided by, so put 1 in parentheses, divided by, parenthesis, a negative 2x plus 4. And we graph this. We should see a vertical asymptote at 2. And as you can see, we do. Where is our horizontal asymptote? Once again, it looks like the x-axis, which is the line y equals 0. So y equals 0 is going to be our horizontal asymptote. Alright, let's pick 2 points to the right of the vertical asymptote and 2 points to the left of the vertical asymptote. As I've mentioned before in previous lessons, you should always make sure that you graph these correctly just by looking at your graphing calculator as well. You should see a graph that kind of goes like this, and a graph that looks like this. So on the top left and the bottom right is where you should have your graphs going. So just double check that on your graphing calculator when you're doing that on your worksheets and on your test. So we're going to go to second graph, which is our table. 2 points to the left of the vertical asymptote, which is at 0.25, and 1 positive 0.5. So 1.5, at 1 it's at 0.5, and at 0 it's at 0.25, which is 1/4. So we're at the top left. Let's follow our asymptotes. And now our next one, remember, should be in the bottom right. So let's make sure that it is when we look at our table. 2 points to the right of my vertical asymptote are at 3, negative 0.5, and 4, negative 0.25. Put those on our graph. At 3, it's at a, what was it again? 3, negative 0.5. And at 4, negative 0.25, which is a negative fourth. So there is our graph. Hopefully no problems there. Let's now talk about our domain and ranges. The more you do of these, the better you get at them because they're all very similar. Once again, your domain is basically negative infinity to positive infinity, except for that vertical asymptote, which is at 2. So it's from a negative infinity to 2, and then from 2 to positive infinity. That's going to be our domain. So for our interval notation, from negative infinity all the way up till 2, union 2 to positive infinity. Which means x such that x belongs all the real numbers except one of them, except 2. X cannot equal 2. So for the range, very similar once again. You go from the bottom up. This red arrow right here goes all the way down. So it starts at negative infinity. It goes as high as 0. It doesn't include 0. So you're going to have a parenthesis right here. And now it's going to pick up on the other side of 0 right over here. So it starts again just above 0, and it goes all the way up to positive infinity. So from negative infinity to positive infinity, except for 0. The way we write that is it goes from a negative infinity till 0, union 0, positive infinity. And then y such that y belongs all the real numbers except 0. Y cannot equal 0. Alright, that's a little bit of a starter on how to do number 1 and number 2. You guys try number 3 on your own. Let me know what you come up with and then check your work with mine after you do it. So please pause the video. Number 3, here's what I got when I did it. The reciprocal function was 1 over 3x plus 9. So we have a vertical asymptote at x equals a negative 3. So this dotted line right there. We have a horizontal asymptote at y equals 0 again. My 2 points to the left of my vertical asymptote are right here. And my 2 points to the right of my vertical asymptote were right here. So your domain is from negative infinity up until a negative 3. Here we are, negative infinity to negative 3, and then negative 3 to positive infinity, which means it belongs all the real numbers except for a negative 3. Likewise, the y is all real numbers except for 0, or a negative infinity to 0, union 0 to positive infinity. Last one, number 4, is kind of a tricky one. There's one more step that we kind of need to do on this one to make it a little bit easier for us. So let's talk about that one really quick. Y equals 1/2 x minus 1. If you put this as a denominator of 1, which is what you're supposed to do, then you use the reciprocal function, which is 1 over 1/2 x minus 1. It's always messy when you have fractions within a fraction, which is what you have here. You have 1/2 x in a fraction. So let's get rid of that fraction by multiplying everything by 2. If you multiply the denominator by 2, you also have to multiply the numerator by 2. The reason why we're doing this is to get rid of any fractions that we have. And if you do something to the bottom, you got to do it to the top as well. So 1 times 2 in the numerator is the number 2. And then you're going to distribute this 2 right here. 1/2 x times 2 is just 1x. And then 2 times a negative 1 is a negative 2. So really, class, this right here is the same thing as this, except this looks a lot cleaner. So I want you to multiply, get rid of the fractions in that way, and then it'll make it a lot neater for you. So our reciprocal function is 2 over x minus 2. G of x equals 2 over x minus 2. So what's our vertical asymptote? Our vertical asymptote is x equals a positive 2. It's when the denominator is 0. What is our horizontal asymptote? Well, let's put it into our graphing calculator. Y equals, clear what you have in there. 2 is in the numerator, put that in parentheses, divided by x minus 2 goes in the denominator, put that in parentheses. Graph that sucker. We have a vertical asymptote at 2, which is great. Our horizontal asymptote, once again, in every problem this lesson, is the line y equals 0, or the x-axis. So let's write that down and put that in our graphs. Y equals 0. So here's our vertical asymptote. Here's our horizontal asymptote. Let's put in the 2 points to the left and 2 points to the right of our asymptotes. So you go second graph. It looks like at 0, at -1, and 1, -2. 0, -1, and then at 1, it's at a -2. Whoopsie. 0, -1, and at right 1, down 2. And then it's going to follow these asymptotes right here. And then 2 points to the right of my vertical asymptote. At 3, it's at a +2, and at 4, it's at 1. 3, 2, 4, 1. 3, 2, 4, 1. And it goes like that. That's what I need to see from you on our next test. And then finally doing the domain and the range. So very similar to the rest of them. It's from a -infinity up until 2, and then from 2 to +infinity. -infinity to 2, union 2 to +infinity. The range is x such that x belongs all real numbers except x cannot equal a +2. And the range has been the same on every single one this lesson, I believe. It's from a -infinity to 0, and then from 0 to +infinity. It goes up until that horizontal asymptote, and then it picks up on the other side again. So from a -infinity till 0, union 0 to +infinity. Which means our y such that y belongs all the real numbers, except y cannot equal 0. Alright, there's our lesson for today. Our worksheet is going to be worksheet 9.3b. If you had no problems with today's lesson, you shouldn't have any questions with the worksheet because it's very, very similar to our notes for today. So make sure you get comfortable with graphing those rational functions. That's going to be a big part of our next chapter test.